Alright guys, so this is the lecture for Chapter 9, Section 3, and in this lecture we're going to talk about the unit circle. So go ahead and get your notes out, but on top of your notes, go ahead and get one of those blank unit circles out that we handed out. Remember, we said you would eventually have to, this is what I'm talking about, the blank unit circle. Okay, that's just part of it, but it looks like this. And we already put in the radians and degrees, but today we're going to be learning how to, I guess, add the coordinates of each of those points. Okay, so make sure you have your notes and make sure you have that. All right, so the first thing we're going to talk about is how we get trigonometric circles when we have angles in standard position. Okay, so we have each of these, like the sine is y over r. So y would be the y coordinate of the point on the circle. R would be the length of the radius. Okay, cosine is x over r. Remember, tangent is sine over cosine. In this case, it's going to be y over x because the r's would cancel. Okay, and so on and so forth for each of these trig functions. Okay, now please do not take your time trying to memorize these, because after we learn the unit circle, or even before we learn the unit circle, after we talk about reference angles, there will be a much easier way to do this. Okay, but for now, let's look at example 1 and use that. Okay, so we want to find the 6 trigonometric functions of this theta here, which is in standard position. So here's my initial side, and then here's my terminal side, and we know this point, -4, 3, is on the circle. Okay, so this is my x coordinate, this is my y. So when we're talking about x and y, -4 is my x, y is my 3. To find my r, okay, I'm going to take this triangle here, and I know it's a right triangle, so I can use Pythagorean theorem. Okay, so if my x value is -4, down here's 4, here's 3. So 3 squared plus 4 squared is going to equal my r squared. It's just Pythagorean theorem. So 9 plus 16 equals r squared. 25 equals r squared. So my radius, guys, is going to be the square root of 25, which is just 5. So my radius is 5. All right, now just from that figure in the previous slide, so just from my figure right here, I'm going to use these formulas here. Okay, so I'm going to do my 6 trigonometric functions. So I can say sine of theta, cosine of theta, tangent of theta. And this is cosecant of theta, secant of theta, and cotangent of theta. Okay, now if I want to go back to that sheet here, just copying straight from there, I know my sine is y over r, my cosine is x over r, my tangent is y over x, my cosecant is r over y, my secant is x over y, and my cotangent is x. My secant is not x over y. My secant is r over x. I jumped the gun. R over x and then x over y for cotangent. Okay, so from here, all I'm doing is plugging it in. Remember, my x is -4, my y is 3, and my r is 5. So if I plug each of these in, y over r, this is just 3/5. Okay, x over r, this is just -4/5. Tangent is y over x, which is -3/4. Cosecant is 5/3. Secant would be -5/4, or 5 over -4 is the same thing as -5/4. In here, this is x over y, so -4/3. Okay, and once again, those come straight from here. All right, so let's introduce the unit circle now. Okay, so the unit circle is basically this circle that we have when we graph angles in standard position, meaning the vertex is at the origin. Along the x-axis here is our initial side, and then this is the terminal side. Okay, so the thing that makes the unit circle special is where it has that my radius is 1. Okay, so all the way around, we're going to restrict this to make our radius 1. Okay, and when we do that, the sine of theta is y over, remember it used to be y over r, now it's y over 1, which just simplifies to y. Okay, and my cosine of theta is x over r, but if my r is 1, it's just x over 1, which is just x. So when I have my unit circle, if I know the coordinates of my point, that means my x value is my cosine, it's the value of cosine, and my y value is the sine. Okay, and it makes things a lot easier. All right, so go ahead and grab that blank unit circle, and we're going to start putting points on here. Okay, we're going to start finding coordinates. Okay, now you don't have to memorize this. If you do, it'll help you a lot. But if you don't, that's okay, because we're going to learn how to find these when you don't have it memorized. Okay, so let's look at this 45-degree angle here. Okay, so that would be here to here. Okay, this is 45 degrees, so this is 45 degrees here. Okay, now, if I break this straight down, okay, what I have is this right angle here, right, where I have 45 and then a right angle. And we all know that 45, that means this and this side are the same. Okay, now my radius, or my hypotenuse, if we put this on a unit circle, which this is a unit circle, because see, this is 0, 1, negative 1, 0, so clearly we can see the radius is 1. My hypotenuse then would be 1. Okay, now remember when we had our 45, 45, 90 triangle, and we had x, 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 square root of 2. Okay, if I had this, if I had the hypotenuse, I could find the leg by dividing by square root of 2. Okay, so that means this side has to be 1 over the square root of 2. Okay, now if we simplify it, I'm going to multiply square root of 2 over square root of 2, so I get just square root of 2 over 2. Okay, so each of these sides is square root of 2 over 2, square root of 2 over 2. Okay, so that means from here to here is square root of 2 over 2. Okay, now notice that's going to be my x coordinate right here, because I'm going right, square root of 2 over 2. Okay, and I'm going up, well, that's this side right here, which is also square root of 2 over 2. So on the unit circle, my 45 degree, this point here is square root of 2 over 2, comma, square root of 2 over 2. Okay, now I can do the same thing in my second quadrant, right? Okay, so this is a 135-degree angle from here to here, but if I break this down into a smaller triangle, this is my right triangle, 180 minus 135, that means this here is 45 as well. Okay, so once again, I have a 45, 45, 90 triangle. Okay, and once again, my radius is 1, which means this is square root of 2 over 2, and this is square root of 2 over 2 as well. Okay, so that means this point here, this length is square root of 2 over 2, and this length is square root of 2 over 2. Now the difference here is here we're moving left. We're moving left square root of 2 over 2, not right square root of 2 over 2. So my x value here will be negative. Okay, and my y value is positive because we're moving up. So this would be here. So really, if you can memorize the first quadrant, the second, third, and fourth would be the same. Okay, same thing here, guys. If I had to build this triangle here, this would be 45 degrees. And so this would be my x coordinate would be negative square root of 2 over 2. And up and down is square root of 2 over 2, but I'm going down, so square root of 2 over 2. Okay, and then same thing right here. This would be positive square root of 2 over 2 because I'm moving right, and I'm moving down square root of 2 over 2, so minus square root of 2 over 2. Okay, so there's 4 coordinates on my coordinate, or on my unit circle. All right, so now look at our increments of 30 here. Okay, so I've done our increments of 45. Now let's do our increments of 30. Okay, now we remember, hopefully, that when we have a 30, 60, 90 triangle, okay, we have 2x, x, x square root of 3. Okay, so there's always this ratio. Okay, so we're going to do the same thing here. What I have this triangle here. Okay, this is 30 degrees. So I'm going to draw it here. This is 30 degrees. Okay, if I can find this length and this length, I can find my coordinate. Okay, but once again, this is the unit circle, so I know my hypotenuse, which is my radius of the circle, is 1. Okay, so notice the short side and the hypotenuse have a 2-to-1 ratio. Okay, so this is going to be half that, so this is just 1/2. Okay, and after I have this, this is the short side times square root of 3, so this is just 1/2 square root of 3, or usually you see it as square root of 3 over 2. Either one is fine though. Okay, so that means here we're moving right square root of 3 over 2, and then we're going to move up 1/2. Okay, so if I had to find my coordinate here, we're right of 0, square root of 3 over 2, and then we're up from 0, 1/2. This would be my coordinate at 30 degrees. Okay, so same thing with 60. Now we're going to look at this triangle here. Okay, so I'm going to draw it down here. And we're going to have those same ratios, right? This is 60 now. My 30 is up here, 90. My hypotenuse or my radius of my circle is still 1. Okay, my short side is still going to be half of this. Okay, and my long leg is going to be the short side times square root of 3, so square root of 3 over 3. These are, square root of 3 over 2. These are pretty much the same thing, just flipped. Okay, so that means from here to here is 1/2, and up and down, this is square root of 3 over 2. Okay, so this point here has to be 1/2, comma, square root of 3 over 2. And here's my second one. Okay, now after you get this quadrant, the second one should be pretty easy, because if we notice right here at 120, right, this once again, I can look at this as just a 60-degree angle, just rotated over the y-axis. Okay, and so I know the length from here to here is still 1/2. The length up and down is still square root of 3 over 2. The only difference is I'm going left of 0, which means I have a negative 1/2. Okay, and I'm still going up square root of 3 over 2, so this is still positive. All right, now same thing with my 150-degree angle. Okay, 150, that means this angle right here is 30. Here's my 90. Okay, and then I can go back to the same thing that this one was here. Okay, so my bottom part is still square root of 3 over 2, right? And my up and down is still 1/2. Okay, the difference is I'm going left square root of 3 over 2, not right, so my x coordinate's going to be negative. And I'm going up 1/2. Okay, so I want you to use these two quadrants, and I want you to try to find the last 1, 2, 3, 4 points on your own. Don't do a whole lot of math. Kind of look at the pattern. Pay attention to your negatives. So pause this, do that, and then we'll go over them. All right, so double check yourself to make sure you have the right points in the right spots. Okay, and after you have this, you should have one unit circle completely filled out where you have the degrees, you have the radians, and now you have the coordinates from each of those on